Good day, students. I warmly welcome you all to yet another session with Mr. Wada Abubakar. In this session, we'll be looking at computer files. What is a computer file in a simple thing? Now, a computer file is how the computer system neatly stores information or instructions so it can be retrieved and used later. Right? It is the smallest meaningful unit of information the computer recognizes and works with. In simple terms, you may think of it as that digital folder page that holds various types of information. Alright, when we say a file could be a text, it could be a number, it could be a picture, it could be what? Video, etc. Now, these files are saved on storage devices like the hard disk, the CD-ROM, the DVD-ROM, the flash drives, the memory cards, etc., ensuring that the data doesn't disappear even when the system is turned off. Now, moving on, let us look at what does computer file contain. Now, at its core, every file that you know, be it images, be it text, be it video, stores information in a binary format. Alright, what do we mean by binary format? That is zeros and ones. Now, however, to users, files appear in various familiar forms, such as the document files, alright, the program files, the data files. Now, document files means what? Files created by users, such as the Word documents that we create using Microsoft Word, alright, the PDF files that we create as well, the personal notes we write or create on the system. These are referred to as what? Document files. Even image files are document files. Even video files are also document files. So long as you create a file on the system, it is referred to as what? A document file. Now, the second file, which is a program file, is a file or a type of computer file or instructions that tell the computer what to do. Right? It encompasses software and the application that we install on the system in order to make the system to work. Alright, so then the third one, which is what? Data files. These store other types of information that ain't programs or documents. Examples include the databases or the raw data about data. Now we have what we call data about data or metadata. Now these metadata are also forms of what? Computer files, because they are needed or required for the computer to work. Now, why are files important? Why are we talking about files? Computer files are fundamental to how our digital world operates. The reason is that they enable a multitude of essential functions, ranging from program execution to system configuration and then to user data storage. Of course, when we say program execution, we are simply referring to what? Files allowing the computer to run programs and software efficiently. Now, that is to say that without files, computers will not be able to run programs and softwares efficiently. Now, with the files, with the availability of computer files, it makes interactive tasks possible. Now, the second one, which is system configuration, is that aspect of computer files that enable what? Applications and system settings, ensuring that computer functions according to your preferences. Alright, so with the files now, the availability or the provision of files, you are able to what? Provide settings, right? Or your preferences to the computer, and computer will be able to store it and work by it. Now, user data storage. Crucially, very importantly, files store all your personal data from assignments, right, and letters to complex spreadsheets and creative projects. Is it databases? Is it graphics work? Is it videos? Now, with all these files we're talking about, these assignments and personal data I've just mentioned, it is made possible with the what? Provision of what? Or the availability of what? Computer file. Now, moving on, we have common computer file terms. Alright, for the data processing students, you'll agree with me that we've talked about this in databases. Now, the first terminology we'll look at here is a field. And what is a field? A field is referred to as a single or simple piece of item of information. Talking about a name, for instance, or let me give an instance. You want to collect student information, for instance. So, student information can include his name, his admission number, his date of birth, his address, his phone number, etc., his NIN, and so on and so forth. Now, each of these items of information, all right, is referred to as what? A field. The name is a field. Alright, his date of birth is a field, his age is a field, his address is a field. Now, a field is referred to as what? A single piece of what? Information. Now, secondly, we have a record. What is a record? A record is a group of related fields. Now, I've just given us some fields of students. Alright, some examples of what? Student fields. Now, the collection of all these fields I've mentioned is referred to as what? A record. Are we together? Now, example include what? Student fields, full details like name, the age, the class, etc. Then we have the elements, data element, the type or description of what a field should contain, e.g. text for name, right? Number for age. Alright, so if you want to create a database for students, for instance, you need to give a description of what each of the fields should contain. So for student name, alright, it should contain text. For student age, it should contain number, etc. Now we also have data item. The actual, alright, value stored in a field is referred to as what? Data item. Is that clear? Now let us move on to the types of data items. We have identified that a data item is what? Is the actual value, isn't it, stored in a field. Alright. So for instance, when you have Amina as a name, 12 as an age, alright. Now this 12 is a value, is a data item. Amina is a data item. Now we have different types of data items. Each data item, alright, that is the actual value stored in a field, can be categorized into 3. Alright, based on the kind of information it holds. Now, this classifications helps computers process and manage data effectively. So, for those that are numerical in nature, we refer to them as what? Numeric data items. Alright. Then, for those data items that are alphabetic, that comprises of alphabets, are called alphabetic data. They comprises of letters. Like the Amina is an alphabetic data. Then the alphanumeric data, right, comprises of what? A mix of the letters, numbers, and symbols. For instance, your admission number comprises of what? Combination of letters and symbols as well as what? Numbers. These are the 3 types of data items we have: the alphabetic, the numeric, and the alphanumeric. Now, moving on, we have file organization. That is how files are arranged. If you are asked what is file organizations, it simply refers to how data file is structured and arranged within a file, making it easy to find and retrieve. Now, the understanding of these terms is key to efficient data management. We have what we refer to as block, the physical units, alright, used to move data between storage devices like the hard drive and computer memory. Then we have buckets, the logical unit used to group and manage data, often larger than a block and organized for convenience. Alright, so take note of these terminologies. Then heat, the number of times data or program is accessed, indicating its frequency of use. Alright, so if you heard the term heat, that is referring to number of times data or the program is accessed, indicating that is how many times that data is being accessed or used. Now, moving on, we have types of computer file organization and the accessing methods. Now, the first one is what? The file organization. We have the serial organization. As the name implies, records stored in the order received. when we say serial file organization, that is, records are stored in the order they are being received. That is, one after another. The first record that comes is stored. The second record is followed. The third record followed, like that. Then secondly, we have sequential organization. Records are arranged by a key. That is, example, student records by ID number. Exactly. Then thirdly, we have index file organization. An index that is used to facilitate faster record retrieval, like a book's index. Exactly. That is, index is provided, or an address, so to say, is provided in order to help or facilitate faster access or retrieval of the record. Then random file organization here talks about what? Storing records anywhere, quickly located via a formula and a key. Right? That is, files can be stored anywhere and can also be randomly worked. So what are the methods of accessing files? Number one, we also have the serial file access, or serially. That is, you access one record at a time in sequential order. You access the first record before you move to the second record. Access the second record before you move to the third record. Like that. Each of the file in the sequence must be accessed before you get the particular one you're looking for. A typical example is a radio. A radio, those old radio cassettes, right? In that, if you want to move to the particular music file, that you want to listen to, you need to fast forward, and you must pass all those music file or song before you get to that particular one you are looking for. So that is serial access of file. Then we have sequential file access. That is, accessing records in a pre-sorted order. Just like we said, records are arranged by a key. Here we use the key that are used to arrange these records to also access the records. Then we have the randomly access of files. That is, you access the files directly without going through other ones. So quickly, let us look at file classifications. That is, the types of files based on use. Right? We have transaction files. These files are recent. They store recent activities or changes. As the name implies, the transactions that are carried out, the recent activities that are carried out or performed. Right? Examples include customer orders, daily sales reports, etc. Now they are temporary. The features is that they are temporary data. They are used to update other data. Then we have master files. Now these store permanent and important records. Example is student database or a school database generally. Customer ledgers. The features include permanent data, large information, etc. File classification continues. We have the third one as well, reference file. This file provides supporting information. Price list, example, dictionary files, lookup tables, etc. And the features include stable and permanent, used solely for references. We have criteria for classifying files. The first criteria here is how the file is used, number of records accessed at the time, speed of accessing records, nature of the content, method of organization, storage medium, etc. And this brings us to the end of our lesson. Thank you very much.